Hello, 30-1s. Here we are in identities again, but this time we're getting at the big part of the unit. We're going to prove an identity here. So these are very much like puzzles. Sometimes the puzzle is easy, sometimes it's difficult. Sometimes you're going to try it for a few minutes and say, I'm not getting anywhere, and scrap it and try again. And like most puzzles, there's more than one way to do it. Couple things I want to point out here as we're going through. We are keeping our formula sheet in front of us. Here's all of our identities that we could use on any single question. And we also need to throw in the fact that we could use things like this, that tan theta is sine theta over cos theta. We could use the fact that cosecant theta is 1 over sine theta. So we can use all of our quotient and reciprocal identities that these are called. So there's a lot we have in our toolbox that we can use. We want to keep these in front of us. Now, there's a couple of important things that I need to see on a written question so that you get full marks on your diploma. I'll tell you as we go through 2 examples. Here we go. Let's prove the following identities and state all non-permissible values. So if I'm telling you to prove it, it's an identity. I can verify it by graphing if I'd like to and see that the graphs are the same, but we're going to prove it. That's what that means. Here's how you're going to attack this. You're going to attack the left-hand side and the right-hand side separately. Now, what I'm going to do first is I'm going to rewrite this down. When you're proving an identity, you want to make crystal clear to the marker every single step, because as I said, there's more than one way to do these. So you want to show to whoever's marking what you're thinking and how you're doing this. Do not leave out any steps, even if to you they are simple. Don't do it. Now, what we're going to do is I look at this and I say, okay, I don't know what to do. Okay, I got to start somewhere. When in doubt, just start trying something. First thing I need to see. I'm going to simplify the left-hand side here. Please give me equal signs down the page. When in doubt, I'm going to turn tangent into sines and cosines. It's not always the most efficient method. You don't know until you start the question, but it's not a bad place to start. Oh, well, look at what happens when I do that. What I recognize right off the bat then is cosine and cosine divide out. Don't say cancel, it divides. It's 1. Okay, what do I have now? Sine theta times sine theta is sine squared theta. Hey, that's pretty simple. Well, okay, let's look at my right-hand side. What could I do? 1 minus cos squared. Well, when I start seeing 1 minus cos squareds, 1 minus anything squared flying around, I'm thinking to myself, is that an identity? 1 minus something squared. Okay, let's go back and look at our formula sheet. Well, I see a 1 and a cos squared there. What if I rearrange this? What if I subtracted cos squared from both sides? Well, that would give me sine squared is equal to 1 minus cos squared theta. And bingo, there it is. This is equal to sine squared theta, just like that. That's it. Look at that. So what we just did was we just showed that the left-hand side is equal to the right-hand side. Now, for full marks on a test and my diploma, I must write a concluding statement. Here are your possibilities for concluding statements. The left-hand side equals the right-hand side. That's what I was trying to show. Makes sense. Left-hand side equals the right-hand side. Okay? Or you could write an abbreviation in Latin. QED. Quod erat demonstratium. What that really means is I showed what I was supposed to. I showed it, baby. I'm sure they didn't say baby in Latin thousands of years ago. Okay, or the other acceptable way is to write this. It's almost like a piece of coding when you're done some work. It's this black box. And for some reason, somewhere along the line, someone nicknamed this the tombstone and it stuck. However you do it, you must write me a concluding statement. There's what you're going to have to do for full marks. Now, a couple of other things that are going to cost you marks on a test. Not having equal signs. Equal signs are showing me equality. You must have equal signs. The other thing I really don't want to see is this. I'll put it in red. You are not putting equal signs between the left-hand side and the right-hand side. That's bad. You're trying to prove it's an equality. You don't know it's an equality. That's what you're trying to prove to me. So please, equal signs down the sides like that. All right? Now, some people in some textbooks like to, instead of writing it like I did, they like to add this in. They like to add in what they call a T, like that. That's also completely acceptable. But again, notice the equal signs going down the sides. You're showing to me an equality as you're working down. All right. Now, we're not done the question. And state all non-permissible values. All right. Let's take a look at this. Well, our non-permissible values, again, come from division of 0. Well, the only place we're dividing by 0 would be in tangent, where cos theta is equal to 0. Okay, so our non-permissible values will be simply where cos theta is equal to 0. Well, thinking of our unit circle, that's going to be at pi half and 3 pi half, right? When the sun's right above me and the sun's right below me. So again, I'll see this a lot as an answer on a test. Well, first off, it should be theta can't equals because it's NPVs, but that's not all NPVs. That's from 0 to 2 pi. So what I really want to see is the general solution of pi half plus pi n a member of the integers. If you felt like writing this in degrees, depends on the question. They would state the manner in which they would like you to write it. That would be 90 degrees plus 180 degrees and a member of the integers. And for giggles, I'll do capital Z because that's the proper symbol. But for some reason in Alberta, we don't like it. We like to use capital I. Okay, there's one proof. What I would like you to do now is to look at this next example, and I want you to try this on your own. So I want you to have your formula sheet beside you. I want you to hit pause on this video. I'm actually going to go eat breakfast, and I'm going to come back and I'm going to prove it after you've tried it for a few minutes. Okay, friends, I went and had breakfast, no kidding, and I hope you tried this. And some of you are probably like, oh, come on. Like, what do I do here while this guy's going to eat food? Well, you go and you look for an identity. But I see 1 plus cos and 1 minus cos, but unfortunately, they're not squared. So there is, when you first look at this, there is no identity at first glance. Okay, this is a very, very, very common one to show up on tests. Here's why. We're going to create the identity. What does that mean? Well, let's start off by doing the left-hand side, right-hand side checks. Left-hand side. 1 plus cos theta over sine theta. Right-hand side, sine theta 1 minus cos theta. I need to make an identity. I don't see it. What I really want to see is 1 plus cos squared or 1 minus cos squared. That's what I want to see because as we saw in the last example, that's an identity. So here's what I'm going to do. I'm going to do a bit of a ninja move. I'm going to, let's go bright purple for my ninja move. I'm going to multiply this by 1 in a super sneaky way. Well, what? Why would you multiply by 1? It doesn't change anything. Exactly. When we multiply by 1, we're not changing the value, we're changing how it looks. All right, smart guy, what are you going to multiply by? This. 1 minus cos theta, 1 minus cos theta. 1 minus cos theta divided by 1 minus cos theta is 1. Okay, why did he do that? Watch what's about to happen. I'm going to leave the denominator alone. But the numerator, I'm going to multiply. I'm going to distribute. Well, if you notice, this is their conjugates. I'm going to end up with a difference of squares. Now you probably see why I did that. Because 1 minus cos squared is an identity. That's sine squared theta. So by multiplying by the conjugate, I was able to create an identity. That's super sneaky, isn't it? Okay, the first time you see it, you're like, oh, I wouldn't have seen that. But now what you're saying is, okay, I've got some experience. I'll see what to do. Okay, now I'm going to divide, not cancel. I'm going to divide. And I get sine theta over 1 minus cos theta. Well, hey, that's the right-hand side. I didn't even have to touch the right-hand side. So let's write a concluding statement. Q, E, D, L, tombstono. Left-hand side equals right-hand side. Write a concluding statement for full marks, friends. All right, last thing we're going to do in this example, we need to find our non-permissible values. Well, our non-permissible values, again, come from the denominator of both sides. So I'm going to search here and here. Okay, let's scroll to the next page where we need a little more room to do this one. Okay, non-permissible values, NPVs. Well, what did we just say? We had, don't even remember, as I scroll down, I'm getting old, sine theta can't equal 0. And on the other side of the equation, 1 minus cos theta can't equal 0. Okay, well, let's stick in radians. That's kind of the common one we get here. So where is sine theta equal to 0? Well, sine theta is equal to 0 at 0 rads, pi rads, 2 pi rads, so on and so forth. All right, if you're thinking of this in the history lesson, that's the sun. It hasn't risen. It's still on the horizon. Okay, what about this one? Well, this would be cos theta can't equal 1. Well, where's cos theta equal to 1? Well, cos theta is equal to 1 at, this would be theta can't equal, that's at 0 rads and 2 pi rads. Well, if we look at that, oh, this is pretty easy to put together as a general solution or a general non-permissible statement. Again, what I always like to do is I always like to write my first angle, even if it's 0 rads, plus I can see the distance between all of these is going to be n pi or pi n, and a member of the integers. And then do I really need that 0? No. Is it wrong if I write it? No. But there it is. Theta can't equal non-permissible values. Okay, there's proofs. What you're going to do is, as you're playing through the lesson, I'm just going to scroll back up here, you're going to come across questions that are going to use all of these identities. In proofs, we don't use sum and difference identities too much. we typically use these and your double angles. When do I use a double angle? Well, notice I see 2s in almost every single one of them. A big hint is if you see a double angle, turn it into a single angle. So if I see any of these, a nice handy thing to do is to switch it into a single angle. There it is, friends. Have fun with identities.